Welcome to Code Club. Please welcome my guest gophers today, John and Thiago. Welcome to you. Thanks for joining. Today we're going to go deep diving again, so everybody got their diving helmets on, securely fastened. Let's go. So one of the most requested standard libraries to deep dive into is http. Not surprising, we use that one a lot, don't we? So let's take a look. We have a program here that uses http to do a get. We should look at the client side before looking at the server side, shouldn't we? Otherwise we don't know what the server needs to do. So this is a relatively straightforward program, isn't it? Shall I just read what we have here and we can deal with any questions that come from this. So we're in package main. We import the net/http standard library package. We have some func main, and inside that we call http.Get to take a random URL, https:/books, probably worth checking out if you have some spare time. So this http.Get takes something, the URL to call in this case. That makes sense. What does it return? Well, nothing we're interested in here. So this program works, doesn't do anything. In order for it to do anything, we would have to look at this. We get back a pointer to an http.response, which is some struct, and an error. So there can be an error, that's worth noting, isn't it? What sort of error could there be? Any suggestions from anybody who might have come across one of these?
Timeout errors?
Yeah, maybe we weren't able to connect to that server for a whole bunch of reasons, isn't it? Maybe there's no server listening there. We timed out while we were waiting. In fact, there are no timeouts with the default HTTP client, which is one reason not to use it. But this is fine for a demo. And maybe the URL is bad. You know, this could be bogus, couldn't it? And there's just nothing Get can do. It can't try to make this connection. It doesn't know how. And the host address could be invalid, or there could be an invalid port specification or something here. Whole bunch of things. Basically, error from http.get means I couldn't do that request. Then, you know, that's distinct from you might do the request, get some response, and the status of the response might be some error, isn't it? You know, 404, 403, 401, 500. These are some of our favorite HTTP statuses, aren't they? And we've all seen these. So that's useful to know when you're the one calling Get and handling some error. The error that you're going to be handling from here is not 404, it's bad URL or something like that. So if we had been interested in the response, probably better to look at this with a web browser and have your credit card ready for buying books. We would get this response object, and it has some things about it like a status code, which would be 404 or not in this case. It also has a body, so there's something in the response, some data, a catalogue of delightful ebooks about learning Go, for example. And the resp.Body is an io.Reader, which is convenient, so we can just read from it in whatever way we want to. So that's all fine, but that's not what we're interested in today, because we'd like to know, how does http.get work? Now, we will be looking at the code to find this out, but let me start by asking the panel, you know, just for your initial thoughts. If you know, suppose that this standard library wasn't available and we had to write this, what things do we know we would have to do, and what would the shape of the solution vaguely look like? Anybody care to just outline it for us?
So for sure we would need to ask the DNS server
Right, or we need to
how
try and...
we resolve the name actually to IP address.
Yeah, we need to make a network connection, don't we? We know that.
Yeah, oh yeah,
And
at the beginning.
it's a TLS connection in this case, but that, you know, is sort of secondary to the fact that we have to do some TCP/IP, don't we? Anybody know how that works? There is a big fat book you can get about it, but I haven't read it for a while. So fortunately, we don't need to know, do we? We know the internet works. So there is going to be some. We hope there'll be some library available which would just say make TCP connection to address X. That could be a host name like this, or maybe a numeric address, IPv6 address, but most likely not. So, and some port, 443 in this case. So that's great. So that's absolutely right. Step 1, connect to the server. What's next? What is HTTP? It's Hypertext Transfer Protocol, something like that, isn't it? So it's some protocol. So what is the protocol? Anybody know?
First, you send a GET and the URI you want for the server and the version of the protocol.
Yeah. It's a text-based protocol, isn't it? So we connect, and the first thing the client does is say what it wants, you know, this URL or something. Maybe some other headers about the types of things we can accept. You know, I don't know the details, but the idea is the client sort of sends some request over this TCP circuit that we've established, and the server will then do some processing and then hopefully respond back with some response, and that can have its own headers and its own body and even trailing headers. This is a little known fun feature of HTTP, that you can send some headers afterwards. Maybe, you know, there's sort of higher level semantics about keeping the connection open or streaming or parallelizing connections and things like this, isn't there? But we needn't worry about all of that. Presumably that's in the standard library, but that's absolutely right. So some of that stuff is going to be happening, isn't it? If we were to use the single most powerful feature of VS Code for learning Go, which is command click, and I'm going to do that in a minute. I'm going to hover over http.Get, and I'll hold down command and click on this, and it will take me to the definition of the get function in the standard library. So I recommend you try this at home with a library that you're interested in. It's really fun. So let's go. Anyone want to venture a guess for the sweepstake on how long this function is? A few lines, presumably. Probably not doing all of the HTTP protocol in that function. But any guesses?
I'd say around about 8 lines.
Yeah. Yeah, but not hundreds. Right. I mean, assuredly there are hundreds of lines behind this function call, but probably not in that top level function. So let's see. No prizes for this one. Okay, only one. But clearly this is just some kind of wrapper. All it does is call some other function. So I'll just read this, practicing our code reading skills. We're in client.go in the HTTP library. And at line 445, we have some function get. It takes a string, which is a URL, and it returns a pointer to a response object and an error. And what it does is it calls the get method on some object called default client, and it passes it the URL that was passed in. So, questions about this? Anybody like to start us off? Is it completely clear what's happening here? Or does this, when we're reading this sort of thing, what questions pop into our minds?
What's a default client?
Right. Yeah, I'd love to know that, wouldn't you? Clearly, it's important. We can guess from the name, so it's not badly named, is it? It could have been called D, that would be less helpful. But default client already tells us, well, in the context of HTTP, that must be an HTTP client, and it's the default one. So this is kind of a common pattern, isn't it, in the standard library and some of the libraries that we write, is we say we have some, the library is about doing something, making web requests in this case, and maybe it's so simple that we just have a function do the thing. That would be great. That's actually the best API you can have. It's like one function. But then maybe there are customizations you can make about how you do that thing, or what you do it to, or how often, or, in this context, things we might set on the client might be timeouts, for example, as John mentioned earlier on. So we maybe have some object, maybe you call new, you
Maybe
get
the agent header too.
Yeah, absolutely. But there will be things to customize about what we're doing. So you can call a constructor, get some object. You can maybe pass it functional options, or you can pass it parameters, or you can set config fields on that struct. Or maybe the struct itself has a config struct. That's not so great. It's more paperwork for users, isn't it? We actually have a type called paperwork, which is terrible. I mean, when you actually typed, type config struct so and so, that should have been a red flag to say I shouldn't be doing this. But never mind, that's a code club for another day. But one really nice thing to do is, if there are sensible defaults for all these options, why make the person call new and then call the do method on the object? Just let them call do the thing. And how would you write that? Well, exactly like this, isn't it? You just have some default object. We'll take a look. And you just proxy this through to its get method. So that's nice. You don't have to customize, but you can. So let's take a look. So what is default client? It's a global variable. That's already, that carries with it a certain warning, doesn't it? We wouldn't want to assign to this, for example. That would almost certainly be a mistake, but we can. So Go does not have immutable variables. That doesn't even make sense, does it? But we have constants. I'm sure you're thinking, what's John talking about? There are constants, that's the thing, you can define them with const. Why not use that? Well, there are some limitations on consts. You might know, let's try to make this a const. We can't. So it's saying, trying to take the address of client literal, value of type pointer to client, is not constant. So a pointer can't be a constant, for example. A struct also cannot be a constant. So what things can be constants? Well, integers and things, basic types, strings, all of that. I better not break this library too badly, had I? Because I need this fairly often. So great. So we don't have constants, or at least not for anything useful. We would love the ability to sort of mark this as final or something, wouldn't we? They'll just say, here's my default client object, and it makes no sense to modify it, and I don't want people to accidentally do that. So I'll just make it impossible for them to do that. We don't have that. One of the many reasons that I think Go probably won't catch on. But we have it. So what is client? It's a struct. So what's in it? Let's take a look. Type client is a struct which has a field called transport, which is a round tripper. What's that? Don't know. Let's move on. it has a field called check redirect, which is some func. The documentation will explain this to us, but let's just sort of intuitively try to guess. What does check redirect do? We know there's such a thing as HTTP redirects, don't we? Like if you request this URL and it sends you back a redirect saying the stuff you want is actually over here. You know, go to this different address. So you could say for any given HTTP client, should it automatically do that? Or should it ask you and say, hey, I tried to get that URL, but it was redirected. What do you want me to do? Maybe the default policy is follow redirects, but you can override it. How would you do that? Well, one nice way would be to allow you to supply some function, isn't it? And that's actually how it works. I don't think, it's not that common to actually use check redirect, is it? I don't think I've ever used it. I doubt anybody here has, but you can, so that's fun to know, isn't it? We have some field jar, which is a cookie jar, something to do with cookies, don't care what. And timeout. We knew this would be here, didn't we? Because we already talked about it. What is that? It's a time.duration. What does it mean? It's when we're trying to make this TCP connection, it may take a while. The internet is not instant, is it? It's fast, but not instant. So it may take some little time to set up this connection. There's a non-zero light travel time through the fiber, a couple of tens of milliseconds, maybe at most. And then there's some processing time on the other end. You know, these packets have to be decoded by some hardware and software, go through the operating system and so forth. But we don't want to just sit there forever waiting for this thing to happen, because it might not. So we'd like to impose some cutoff saying, yeah, if it takes more than, 10 seconds, just forget it. Clearly something's wrong. You know, if it's not come back after 10 seconds, it's probably not going to. Or the ops team on the other end really needs to work on their metrics, don't they? Their P90 latency is going to be terrible. So that's what the client struct is. So let's go back. Okay. So that's what that is. So we're calling its get method, passing it the URL. Let's take a look. Okay. This is starting to look closer to the bit that does the stuff, isn't it? We know there's going to be something that opens a network connection and then starts talking HTTP over it. We didn't get that far yet, but let's see how close we can get to it. So we are a method on a pointer to client called get. Why are we a pointer method? That anybody know? Just offhand? Because there's an easy rule to remember for this, and I say it about once a day.
Because we're modifying the client structure.
Right. Because without that pointer, we couldn't modify the client, could we? Or we could perfectly well modify our local variable C, which is the receiver of this method, but it would have no effect on anything else. That's just local. Whereas if we have a pointer, that means it was explicitly shared with us, so they want us to modify it. And we can.
I do have a comment about it, because I on Wednesday I was going through the Go tour, and they say that you never should mix pointers, receivers pointers and receiver values, because you should have a pattern. I didn't get that very well. So, because it's exactly the opposite we have been seeing here, right? Do you have any idea why this information may be there?
Yeah, any thoughts on that, panel?
As general idea, not to mix semantics. If we have, for example, one struct, then if we have methods that will require the modifying of the struct, then all the methods that we should use basically the pointer semantic, not to mix.
Yeah, because here, even in the get function, I'm not seeing any change to the client object.
But there may be some hidden change. So we're going on to call another method in a minute, which may affect it.
Yeah.
So yeah, I think, yeah, go on.
No, I was just, I just didn't understand why it was in the documentation, in the code, because it doesn't make sense for me to. I think it's even safer if you don't pass the pointer, if you don't need it.
Yeah.
You don't need to change the object.
Yeah, that's right. Well, I mean, there are some things in the tour of Go which aren't necessarily the best advice now. Perhaps it was true once, or a good idea once. It's still wonderful, though. I mean, if anybody hasn't seen the tour of Go, they should definitely go to it and have a look and run through it. It doesn't take long, and it shows you essentially everything in Go, doesn't it? It neglects to say that some of those things you shouldn't actually do. But nonetheless, that's not really its job. Its job is to tell you what is in Go. Let's have a tour of it, including things like naked returns, which we know you can but shouldn't do, and lots of other things. As far as pointer methods go, I mean, I don't want to, just to be clear, I don't want to sound as if I'm saying if you're not sure what a method with a pointer receiver means, or how to choose between pointer and value receivers, that it's sort of obvious. I don't think it is, but luckily there is a really simple rule, which is exactly the one that Jakub said, is if it modifies the thing, it must take a pointer, because without that, it can't have any lasting effect on the thing. This client here, if that wasn't a pointer, then suppose we assign to some field of C, like timeout. Well, that would affect our local variable C, but it wouldn't affect the value that somebody else has that they're calling this get method on. Their C would be unmodified. That's probably not what they want, which is why the method takes a pointer. And I think Thiago's question was about, like, if you have some methods do not need pointers because they don't modify the thing, but some do because they do. So is it okay to just have a mix of pointer and value methods like that? Or if you have some pointer methods, should you just make all your methods take pointers? I can see the argument for that in the sense of, it's less confusing for readers. They just know all of these methods, just take a pointer, that's fine. And maybe that makes sense, but also I think it's sort of, it sends useful information, doesn't it? Having this pointer tells you that this method's purpose is to modify the client, indirectly in this case. And if it took a value, we would know that nothing that happens inside this method, or any functions it calls, or any other methods, none of those will ever modify the object. Because if they do, then it's simply a bug. We would need to take a pointer here.
I think the big advantage of making it consistent between having one type returns pass a pointer in or not is when you start using channels, and then it means for the consumer of this, they're very clear about where that state is being stored and modified. And if you're mixing it, then that's another thing for the programmer to keep track of. It might be better if that's necessary to have a high-level API that hides all the mess away from you and then doesn't need a pointer, a method pointer.
Yeah, and there can be subtleties here, can't there? Because there are things which do modify the object, but we wouldn't necessarily assume that they would. Like read, for example. We're familiar with things that have read methods on, and the conventional signature of read is that it's, it operates on some pointer. Why is that? Because read doesn't sound like it's modifying, but in fact a reader knows where it is in the reading, doesn't it? It's sort of keeping a bookmark to the point that it read up to, and then if you call read again, it'll read some more from there. So of course when you read, you modify that, don't you? You modify the little bookmark that tells it how far it read. So that's a good example of sort of implicit modifying. So one nice thing to think about here is that it's never wrong to have a pointer method. Because if you don't modify the object, fine. You do you. You don't have to. So it'll always work. The reverse is definitely not true, is it? It's not okay to just have all value methods. Because some of those, the ones that need to modify the object, just would stop working. So it's always okay for your methods to all be pointer methods. It's not always okay for your methods to all be value methods. Does that help, or just muddy the issue further?
Oh, that's helpful. Thank you. And so sorry for the off topic.
No, not at all. I don't think there is an off topic.
Okay.
So this is great. So we have this get method, and we understand what that's about. Now it returns the same thing as http.Get returns, a pointer to response and some error. So what does it do? Well, we call some function new request. We pass it the string get in capitals and the URL that we have and nil. What's that? Don't know. This is why functional options are so great, isn't it? Because you can say what it is. What is it? It's a body. Okay, fine. So you could imagine that this is something like with body, isn't it? Strings, new reader. Hello. Great. That would be much better. It's clear to everybody what this thing is, and if we don't care to pass a body, we can just say with body nil. But of course, we just wouldn't say that at all, because the great thing about functional options is you don't have to provide them. So this, however, this API dates from the before time, before we had those things. So it's mandatory, and if there's no body to the request, what would that body be? Well, you could imagine some form data or something, isn't it? If this were a post request, we might be posting some form data, or just a bit of JSON or something. But we're not in this case, because it's a get. So what does new request return? Well, a request. There's good naming going on here, isn't there? And we sort of expect that from the standard library authors, but sometimes it's easy to take this stuff a bit too much for granted. This name makes it really clear what it does and what it returns. And calling this variable rec, R-E-Q, sort of helps as well. So and we check the error naturally, because new request might fail. What do we think new request does, and what might go wrong with it? Any thoughts? Does it do the request, for example?
We're expected to do just to create some sort of object, which is then passed into request. So presumably there are things that can fail. Maybe the size of for example, the nil we pass in as some sort of body is too big for a single request. Maybe there's some limits there. Maybe the first parameter we passed in isn't valid for some reason. Maybe the URL isn't valid. So I would expect the new request function to do sort of the paperwork.
Yeah, that all sounds believable, doesn't it?
Valid, and then either that should return some sort of structy objecty thing, and then pass that down to there we go, to do client.do to actually do some real work.
Yeah, that makes sense, and it's this pattern that we talked about earlier, isn't it? It's like if I'm calling new something, that means I'm constructing some object that I'm then going to use to do the thing. I have to pass it some parameters, because if there were no parameters, I wouldn't need to call new, would I? I could just call do the thing. The fact that I need to call a constructor to get the thing doer and then call do on it implies that there's something I can configure about it. And if it takes parameters, then they could be wrong, couldn't they? Somehow. Whatever wrong means in this specific situation. So new request takes we guessed that this string represents the method, in this case get. So HTTP has different methods: get, post, put, delete, and probably others, but we don't often use them. So this could be wrong, couldn't it? There could be, in fact, no such method. Method could be something like bogus. And in fact, we would really like to just have defined constants for these. And I believe we do. There's one called method get, which is just precisely that string, the string get. And it's nice for us to use these in our programs, not because we're worried that we might get the word get wrong, but, you know, it so happens that the value of get actually tells you what it is, GET, but it might not have done. Status codes are a good example of this, aren't they? We could have looked at the response status code and said, is it the value 404? Well, fine, but what does 404 mean? We know, but that's just something we know, isn't it? We weren't born knowing that, we had to learn it. So it's really useful to have some named constant like http.status not found, which has the value 404, but communicates that more informatively. So this is good though. I should submit this, shouldn't I? Shall I open a PR for this? Well, let's finish our refactoring first. So yeah, so as Dave said, we get some error because we must validate our parameters, and it could be the bogus URL thing that we were talking about. That's one thing. And then, having established that we have this request object, which we haven't done the thing yet. This is the thing doer. We call not a method on the request, but a method on C, that is the client that we're a method on. So we're the get method of the client, and we call our own do method, and we pass it that request. What does do? Well, you can sort of guess, can't you? This is good naming. Again, it's short, unambiguous, completely communicates what its purpose is. We would all love to be able to write methods with names like this, wouldn't we? So let's take a look. Okay, we are a method on a pointer to client again, and the name is do. We take a pointer to the request. We return a pointer to the response. So clearly, by the time we return, we have done the thing. We've made the connection, spoken the protocol, got the response, or not. What do we do? Well, we call another method called do on the client and pass it the request. So what's this about? Any ideas? Why does c.do just call c.do?
I think it's to enable external tests, maybe.
Can you say a little more?
Like you cannot call the do with a small d because it's unexported. So if you need to call from someone else external to the client package, you need to export this function. And I've seen a couple times when people just use the same function name with a capital letter in the first.
Yeah. Yeah, I think there could be a few different reasons for doing this, couldn't they? Of which that's definitely one, is we'd probably like to test that method. And we don't really want to make it part of our public API, but if we want to test it externally, we have to. But by doing this, we're strongly sending the message, nothing for you here, right? When you see this, it's like, oh, this public API method just calls an unexported internal method. So it's probably not something I'm going to need to call as a user. Maybe we do, you know, that's possible. But clearly this, the lowercase do is the thing that's going to do the business. So here we are. So another method on the pointer to client, do, this time unexported, takes the pointer to the request and it returns pointer to the response, and error. So what's the first thing we do? First thing we do is we look at some variable test hook client do result, and we say, is that non-nil? Because if it is, we're going to defer something. What are we going to defer? We're going to defer an anonymous function literal which calls whatever the value of test hook client do result is with our named response result and our named error result. So there's a bit to unpack here, isn't there? Anybody like to have a go? Venture a guess at what they think this is doing. We know the type of this. It's some func. So we're saying this is some global variable, test hook client do result. It's not initialized. So its type is this kind of func, but it has no value unless someone somewhere sets it. So we're looking to say, has this been set? Its name contains hook. So this sort of, we can infer from that this is perhaps a way of hooking into this do operation if we need to do some special extra little bit of logic or something. So what effect does it have? What does setting this variable cause to happen? Anyone like to guess?
So my reading of this is this allows us effectively to, irrespective of what the actual test does, return a predefined result probably. So if the hook has been enabled, then the last function we run at the end of this function, so the one that returns a result, will be whatever test hook client do result does with the values of ret res and ret error that we have at this moment. Right. So effectively, if I phrase it differently, at the end of this function, we get to call test hook client do result with the values of the ret res and ret error that we have at this time.
Yeah.
Which to me doesn't really make sense because they're uninitialized.
Yeah, there's some subtlety here, isn't there? So first thing we might ask is, okay, you're saying if you've provided this hook, then run it, call it at some point. When? At the end. So using defer here says, when this method do, when that exits, however it exits, run this. What's this? Well, it could have been just defer test hook client do result, couldn't it? So it could have been this. What is it that we defer? It's a function call, and here it is. So why not that? Because instead we've wrapped this in an anonymous function literal which does nothing but make that function call, isn't it? Any idea what that's about?
We don't want to evaluate the result of it now, but we want to close over the parameters it has. So I guess this is sort of currying really. Here's the parameters to the function, but don't actually evaluate it until we get to the end.
Right. Yeah, this is a slightly subtle point that not everybody is aware of about defer, is that when you say defer some call, of course the call doesn't happen yet, that will happen at the end, but evaluating its arguments happens now. So if we were to just defer hook, ret res, ret error, we would take whatever the values of these are now, which we know is nil and nil, because we haven't done anything with them yet, so they'll have their default values. And that's what will be passed to the hook function, regardless of anything that might happen to them during the rest of this method, isn't it? So the next thing that happens after this defer call might be set ret res to something. And now when this defer happens, we will execute this anonymous function literal, which will say, what's the value of ret-res now? I.e., at the time I'm calling this hook function. So as Dave said, that presumably is what makes the difference. That's why we wrap the call to the hook inside this anonymous function literal, so as to put off evaluating its arguments until later.
It's a terrible thing to do. It's like the whole point of defer is that you close over the stuff and then it's sort of stored on the stack until later. And what we've got here is this presumably very useful trick to allow us to subvert the very reason you use defer.
Yeah.
Right.
Just one question. Shouldn't I need to pass the variable, like should the closure to make sure it's going to evaluate that? Like between the parentheses at the end.
Are you saying you could put ret-res and ret-error as arguments to the anonymous function literal?
Yeah.
Yeah, that wouldn't make any difference because they'd be evaluated now as the defer statement is executed, not when it's actually fired, if you like. So what defer does is it sort of stacks up all of these things to do later, isn't it? And then when the function exits, it says, oh, I remember I deferred some stuff. What was that again? Let's pull that out. But the arguments are already prepared.
I see.
So,
I could use a closure, maybe.
Yeah, this func is a closure, isn't it?
So basically, ret-res and ret-error, we have access to this function when we will executing this deferred function at the very end, right? Of the main function, we have access to this ret-res, ret-error, whatever values we will set up later on in this function, correct?
Yeah, that's right. And we can infer something from that, can't we, about the purpose of making this hook available is to say, well, you could just supply some hook function that gets called at the end, but what would it do? Nothing useful unless it could modify the response in some way. Or it had access to what was going to be responded. And the error, so a hook might be, what could you do in a hook? You could say, we've made the request, talked to the server, got the response, we're about to send that back to the main program, but we want to do something to it first. We want to filter out any obscene, treasonous, or potentially seditious content, maybe. We might be a great firewall, for example. And we can do what we want, can't we? Because we have the response, we have its body, we can rewind and rewrite it, do whatever we want, replace it with some different response. No soup for you. We could do anything. But we need that response, and what we don't need is its value now at the start of the function because we don't have anything yet. So we put off looking at ret-res until the deferred function is fired, if you like. So that's kind of cool, but I don't know what... this test hook, it starts with the word test, so sort of implies it's for testing, doesn't it? And it's unexported, so I can't set this as a user. So that's even more helpful, isn't it? Because if we were writing tests for this machinery, we might very well want to do something like that. So that's helpful. Okay, what's next? So
just one question about this. So the sort of general pattern to me looks like here's a clever way to override the internals of a function which may have multiple sub-functions underneath it. So we know we're going to do some DNS stuff, we know we're going to do some network stuff, and then we're finally, at the end of all of that stuff, going to get to the thing we actually want to test. And we can just bundle all of that stuff up and say, I don't care what happens inside the test, I just, inside the rest of the function, I just want to see these results here. But to me, that would, I'm expecting to see somewhere else in the program then like a table test of input request and then like wants and gots, ret res, ret error, but I'm not going to have that because I don't pass into that closure the actual request itself.
Yeah.
So this is kind of weird. You're allowed to modify the response as much as you like, but you don't know what the request was at that point.
That's a good point, yeah. So yeah, and this is not exported, so external tests could not set this. This must be some internal test. Fine, and maybe, in order to do that any other way, you'd have to inject that hook function somehow, which would mean everybody would have to pass it, even when they didn't want it. So that's interesting.
So that was the main thought for me here, was this would be useful when the rest of my HTTP client library, I want to test all sorts of things about how we process headers and how we handle the body and so forth. But for those tests, I really don't care about the actual network effort inside that. Yeah. And this would be a way to skip it. But for that to be useful, I would need then to pass this test hook client do result. Would also need to have the request.
Yeah, makes sense. So now that we've deferred that bit, what do we do? We look at the request. We look at its URL field. What's the request? It's a good time to look at that, isn't it? It's some struct pointed to request. Can we find one? Let's just go look. It's got a method. We knew that because we had to pass it to the constructor. It's got a URL, also makes sense. That's not just a string, it's some URL.URL type, which is a bit more sort of, that information is broken down into things like what's the scheme, what's the optional user and password info, what's the host, what's the path, is there a query string, and so forth. But that's all part of the request. Proto is like HTTP 1.0 or whatever. Proto, major, and minor. Header, we know there are request headers. That's a struct of its own. Body, we know. Get body, content length, and some other stuff, and we don't really care about these. But there's a bunch of stuff here. We look at the request URL and we say, is it nil? Because if it is, here's what we're going to do. We're going to call a close body method on the request, and we're going to return for the response nil, and for the error, I pointed to a URL.error struct. What's that? It's a struct which has some field op, which is a string, a URL which is a string, and error which is an error. So we could have presumably just returned error, errors.new, or even func.errorf nil request URL, couldn't we? But we do a little bit more. We have a special struct for this. What can we infer about this struct type, by the way?
I'm actually wondering why URL would be new, since we have a new function like a constructor. Like, wouldn't be the constructor setting the URL from the beginning?
Yeah, we constructed that request, didn't we? So let's just remind ourselves how we got that. We got that by calling new request, and we passed it a string, which is a URL. So inside that, we needn't look too deeply into this now, but we're constructing this request object to return a pointer to it, aren't we? And we pass that URL, trying to construct this URL struct, which has all of the various different bits that the string kind of encodes. And presumably we return a valid request object with a real URL, or we would have complained already. That was your point, wasn't it, Thiago?
Right.
And so, but the problem is that request has been around the block a couple of times. by the time it gets to this point. So maybe this is an exported field, so maybe somebody just assigned nil to it. That would be a bit antisocial, but we can imagine them doing that. Maybe not even on purpose. So we need to check again here. Anytime you have some exported field, this kind of thing can happen, can't it? People, it's like when I lived in London, people would always throw rubbish over the garden wall. Not sure why, but every Londoner knows this phenomenon that you come out in the morning and you just have a load of garbage on your front lawn. So this sort of thing can happen with structs. People throw garbage into your fields, and so you need to check them. The way to avoid that would be to make the field unexported, and ideally, if people need to set it, give them some validating accessor method that they have to go through. So we don't have that here because it's okay to just check if it's nil. So what do we do? Well, close body. What is body? Well, we said the request.body is some io.Reader and indeed closer, and we've set up this request all ready to fire off, haven't we? We're about to fire it any minute now. Except we just discovered the URL is nil, so actually there's nowhere for it to go, but we still have this body sort of sitting there waiting to have stuff put in it, and if we didn't close it, it would just leak in some way. You know, that memory has presumably been allocated on the heap and will never be garbage collected because this dangling pointer will be around. So we close it just to say, nothing to see here, you know, please move along. We're going to throw this away, so we're cleaning up all our resources. And now we return nil response, which makes sense, we never did the request, and this custom error struct that says, not only was there this error, nil request URL, but here's, well, what is op? It's a string. We set it to the value of calling URL error op and passing it the method. Let's just see what that does. As it says, if the method is empty, then return get. Otherwise, return a slice of method from the first rune, no further, just the first rune, plus strings to lower a slice of method from the first rune to the end. So that's probably that's an overcomplicated way of saying something quite simple. Maybe you can guess or infer what this is doing. If I said to you it's the first letter of the string, whatever it is, plus a lowercase version of all of the rest of the string, that makes it clearer, doesn't it? Maybe not. Yeah. But slightly less obscure, shall we say? So there's something, we can guess that this is about the method, get as it might be. So we're saying there was a nil URL error when trying to do this request with method X. And we don't want to say get in all caps because it sounds like we're shouting angrily on a Slack channel. We just title case it. So with capital G, lowercase et. Don't know why. There's probably a fun issue about that somewhere, isn't there? You know, what are the Go issue tracker numbers up to now? Like 74,000 and something, you know. Issue 12 was probably about, like, you know, title case method when returning request error. So it's not nil. We've established that. We've done some cleanup and bailed out. If it is nil, now we know it isn't. So let's get on. So let's declare some variables. Why did we wait till now to do that? Doesn't it seem more logical to declare all your variables right up at the top? Why wait?
I think it's more friendly to declare them nearer their use, though, if you possibly can.
Yeah, that's definitely one big thing. Is it's when we come across, for example, deadline. But our first question will be, well, what's that, and what's its value? And if we defined everything at the top of the function, that could potentially be a long way away from where it's used. The other thing is we may not actually need it, isn't it? We're going to be allocating some memory here, but maybe we don't need to, because if the request was nil, we're just going to bail out. And this happens or not, regardless of the variables. So I think, I think it is conventional style in some languages to declare everything up front, or maybe that's even required. In Go, I think it's much more common to declare each variable just right before you use it, isn't it? I mean, here we did a whole block of them. Maybe that's just to keep things a bit tidy, but we definitely don't start declaring variables until we're sure we're going to need them. That's useful. So what do we have? We have a deadline variable, and we set it to the result of calling c.deadline. This is some method on the client. It returns a time.time. Any guesses? I think we can figure this one out, can't we? Again, the name deadline is quite suggestive, isn't it?
I should think it means that if the request isn't complete within that time, then we stop.
Yeah, I think that's right. So it's a time.time, so not a time.duration, you notice. So what's the difference? I mean, they're both seconds values, nanoseconds values actually. The time.time is nanoseconds since epoch, 1970s, which is when the world began, as we all know. No point referencing any times before that. Nothing interesting happened then. But a time.duration is just some span of seconds. So what do we think? So deadline is some specific clock time, isn't it? It's 4:05 today. So how do we get that? Where does that come from? What do we think c.deadline does to calculate it? Why would there be a deadline?
When we created the request object, they can new request presumably already, and it looks kind of like when it creates that object, it will pick up. It will have some internal default which we haven't overridden, and then it will whack that onto the current time and say this is when you should be finished by, and that means the rest of the code doesn't need to do any calculations about am I close to the start or the end of the duration path. It just knows, irrespective of the history, am I done at this point in time or not? If I haven't reached completion by the time has passed, I should bail.
Yeah, that sounds good to me. We know there's some timeout field on this client, isn't there, which can be set. It isn't unless we set it, but it can be set. If it is, it doesn't make sense. If you're later on in this method trying to work out, have I hit the deadline yet? How would you do that? Well, you can say that the timeout was 10 seconds. Have we used 10 seconds yet? Well, who knows? We don't know when we started, do we? So much more sensible thing is to say, first thing we do, let's say, what's the timeout? Okay, what's the time now? Add those two things. That gives us the wall clock time when we should end. And then figuring out if we've hit the deadline becomes easy, doesn't it? It's just saying, is it that time yet? So I think that's what deadline does. Yeah, kind of looks like it, doesn't it? Deadline says, if c.timeout is greater than 0, i.e. if it has been set, because if it hasn't, it will get its default value, which is 0. If it has been set, then call time.now to find the time now. More great naming. This is worth paying attention to, isn't it? Time.now returns some time, and it has an add method. We could have just used the plus operator to add these things, but with times, nothing is ever simple. All programmers know date and time. It's never simple. So there is an add method on a time.time that you can call to say add some time to it. We add the timeout value. That gives us the wall clock time at which to end. Brilliant, and we return it. And if not, well, that means the timeout wasn't set, so we return some empty time.time, which is interesting, isn't it? Because that's our deadline if no timeout has been set. is not, it's not 0 or Friday next week or year 2034. It's just empty time. So you could imagine, if it was just 0 to say, please don't consider this a time. Well, what is a time.time? We just said it's seconds since epoch, isn't it? So a time.time of 0 would be, midnight January 1st, 1970, or whatever it actually is. And if we said, hey, have we reached that time yet? Well, we definitely have, haven't we? In fact, we're well over deadline by about 50 years. So that would definitely be the wrong way to do it. So there's a before, and I think there's before and after methods on times, isn't there? So you can say for some given time.time value, is it before this other value? Which would presumably be what happens here. So we didn't quite get to the bit that does the stuff yet, but we found some interesting things, didn't we? And we're sort of more or less coming to the end of our time. But should we, are there outstanding questions, comments, worries, complaints, or just closing thoughts?
Yeah, I have a complaint. The time is too short.
Yeah, I agree. But don't worry, tune in next time and for the next 18 months thereafter as we continue to work our way through the HTTP code until we get
Need
to
to
the
extend
end of it.
deadline.
So yeah, I mean, it can take as long as it needs to, It's your own time you're wasting in a sense. So yeah, any other thoughts?
There's a surprising amount of wrapper, what I would loosely call boilerplate, that still gets in the way even at sort of runtime, outside test time, just to get to this point. We've done, many comparisons, gone through many functions for all that. And that's a lot of work, just in essence to shove a pre-prepared piece of string down a TCP socket and get a response back.
Yeah, I know. I feel the same, and this is true of programming in general, isn't it? Is that it always seems so simple in our heads. We just think, yeah, just open the text editor, just start writing, open the socket, send some text, get something back, job done. And then someone says to you, yeah, but what about this special case? What if the URL is empty or something? You're like, well, what are you talking about? Of course it won't be. What kind of idiot would try to do a request to an empty URL? Well, there will be someone. It's like when Homer Simpson says, because of me, they have a warning. Some Homer Simpson tried to do that, and now they have a check. And there are so many little bits and pieces, as Dave said, to check about things, plus wrappers that you need to build in to facilitate testing and to organize code more sensibly or to reduce duplication or whatever. And it always ends up being a lot of, for anything you want to do with Go code, like call HTTP requests, there's some machinery, isn't there? The thing that does HTTP, for example. But usually we need a lot of support stuff to enable that machinery and expose test points and things like this. So there's sort of machinery, isn't there? And it's amazing just how much of that stuff there often is. Very often the machinery itself is quite small, but the machinery is enormous. So if that happens to you, don't worry, it's okay. Or if not okay, it's at least normal. So let's wrap it up there for today. Thanks very much to my panel. This has been fun and interesting, I hope. It certainly was for me. And I will see you all next time. Thanks for watching.
Thank you.
Thank you all.
Happy Easter.